10 machines and systems that anticipated technology decades ahead of adoption. This countdown moves from number 10 to number 1, with each archive leading into the next. We begin with difference engine, the invention that arrived too early. A difference engine is an automatic mechanical calculator designed to tabulate polynomial functions. It was designed in the 1820s, and was created by Charles Babbage. The name difference engine is derived from the method of finite differences, a way to interpolate or tabulate functions by using a small set of polynomial coefficients. Some of the most common mathematical functions used in engineering, science and navigation are built from logarithmic and trigonometric functions, which can be approximated by polynomials, so a difference engine can compute many useful tables. The mechanism surrounding difference engine led to analytical engine, where another part of the modern world was anticipated. At number 9, analytical engine, the invention that arrived too early. The analytical engine was a proposed digital mechanical general-purpose computer designed by the English mathematician and computer pioneer Charles Babbage. It was first described in 1837 as the successor to Babbage's difference engine, which was a design for a simpler mechanical calculator. The analytical engine incorporated an arithmetic logic unit, ALU, control flow in the form of conditional branching and loops, and integrated memory, making it the first design for a general-purpose computer that could be described in modern terms as Turing-complete. In other words, the structure of the analytical engine was essentially the same as that which has dominated computer design in the electronic era. The mechanism surrounding analytical engine led to Jackwood machine, where another part of the modern world was anticipated. At number 8, Jackwood machine, the invention that arrived too early. The Jackwood machine, French, jacquard, is a device fitted to a loom that simplifies the process of manufacturing textiles with such complex patterns as brocade, damask and matelassé. The resulting ensemble of the loom and Jackwood machine is then called a Jackwood loom. The machine was patented by Joseph-Marie Jackwood in 1804, based on earlier inventions by the Frenchman Boisselet-Bouchon, 1725, Jean-Baptiste Falcon, 1728, and Jacques Vaucanson, 1740. The machine was controlled by a chain of cards, a number of punched cards laced together into a continuous sequence. Multiple rows of holes were punched on each card, with one complete card corresponding to one row of the design. The mechanism surrounding Jackwood machine led to Pascaline, where another part of the modern world was anticipated. At number 7, Pascaline, the invention that arrived too early. The Pascaline, also known as the arithmetic machine or Pascal's calculator, is a mechanical calculator invented by Blaise Pascal in 1642. Pascal was led to develop a calculator by the laborious arithmetical calculations required by his father's, Étienne Pascal, work as the supervisor of taxes in Rouen, France. He designed the machine to add and subtract two numbers and to perform multiplication and division through repeated addition or subtraction. It used a stylus to perform calculations. There were 3 versions of his calculator, one for accounting, one for surveying, and one for science. The accounting version represented the livre, which was the currency in France at the time. The mechanism surrounding Pascaline led to Curter, where another part of the modern world was anticipated. At number 6, Curter, the invention that arrived too early. The Curter is a handheld mechanical calculator designed by Kurt Hoestark. It is known for its extremely compact design, a small cylinder that fits in the palm of the hand. It was affectionately known as the pepper grinder, or pepper mill, due to its shape and means of operation. Its superficial resemblance to a certain type of hand grenade also earned it the nickname, math grenade. Curters were considered the best portable calculators available until they were displaced by electronic calculators in the 1970s. The mechanism surrounding Curter led to Theremin, where another part of the modern world was anticipated. At number 5, Theremin, the invention that arrived too early. The theremin, originally known as the etherphone, thereminaphone, or thereminvox, is an electronic musical instrument controlled without physical contact by the performer, who is known as a thereminist. It is named after its inventor, Leon Theremin, who patented the device in 1928. The instrument's controlling section usually consists of 2 metal antennas that function not as radio antennas but rather as position sensors. Each antenna forms one half of a capacitor with each of the thereminist's hands as the other half of the capacitor. These antennas capacitively sense the relative position of the hands and control oscillators for frequency with one hand, and amplitude, volume, with the other. The mechanism surrounding theremin lead to mechanical television, where another part of the modern world was anticipated. At number 4, mechanical television, the invention that arrived too early. Mechanical television or mechanical scan television is an obsolete television system that relies on a mechanical scanning device, such as a rotating disc with holes in it or a rotating mirrored drum, to scan the scene and generate the video signal, and a similar mechanical device at the receiver to display the picture. This contrasts with vacuum tube electronic television technology, using electron beam scanning methods, for example, in cathode ray tube, CRT, televisions. Subsequently, modern solid-state liquid crystal displays, LCD, and LED displays are now used to create and display television pictures. Mechanical scanning methods were used in the earliest experimental television systems in the 1920s and 1930s. The mechanism surrounding mechanical television lead to pneumatic tube, where another part of the modern world was anticipated. At number 3, pneumatic tube, the invention that arrived too early. Pneumatic tubes, or capsule pipelines, also known as pneumatic tube transport or PTT or points or pneumatic tube systems, are systems that propel cylindrical containers, carriers through networks of tubes by compressed air or by partial vacuum. They are used for transporting solid objects, as opposed to conventional pipelines which transport fluids. In the late 19th and early 20th centuries, pneumatic tube networks were most often found in offices that needed to transport small, urgent packages such as mail, other paperwork, or money over relatively short distances, with most systems confined to a single building or at most an area within a city. The largest installations became quite complex in their time, but have mostly been superseded by digitization in the information age. The mechanism surrounding pneumatic tube lead to Stirling engine, where another part of the modern world was anticipated. At number 2, Stirling engine, the invention that arrived too early. A Stirling engine is a heat engine that is operated by the cyclic expansion and contraction of air or other gas, the working fluid, by exposing it to different temperatures, resulting in a net conversion of heat energy to mechanical work. More specifically, the Stirling engine is a closed-cycle regenerative heat engine, with a permanent gaseous working fluid. Closed cycle, in this context, means a thermodynamic system in which the working fluid is permanently contained within the system. Regenerative describes the use of a specific type of internal heat exchanger and thermal store, known as the regenerator. The mechanism surrounding Stirling engine lead to Tesla turbine, where another part of the modern world was anticipated. At number 1, Tesla turbine, the invention that arrived too early. The Tesla turbine is a bladeless centripetal flow turbine invented by Nikola Tesla in 1913. It functions as nozzles apply a moving fluid to the edges of a set of discs. The engine uses smooth discs rotating in a chamber to generate rotational movement due to the momentum exchange between the fluid and the discs. The discs are arranged in an orientation similar to a stack of CDS on an axle. The Tesla turbine uses the boundary layer effect, instead of the method employed by more conventional turbines, wherein a fluid acts on blades. The Tesla turbine is also referred to as the bladeless turbine, boundary layer turbine, cohesion type turbine, and Prandtl layer turbine. That was top 10 inventions that arrived too early. Every story in this countdown began as a shorter archive, but the connections only appear when the files are placed together. Subscribe for the next collection.